Hi students, good evening everyone. Am I audible to everyone? Am I audible to everyone? Please give a thumbs up. If I am audible, please give me a thumbs up. Yes, thank you, thank you so much. Anusha Gowda, when is result? I have not started the class. How can I say the result? Okay, don't worry, your result will come soon, and all the best. You will get very good result also. Okay, well, so before this there was a one class. That class was not able to take because of the heavy rain, and also it is a thunderstorm was there. That's why we couldn't take the class. So sorry for that. First and foremost, I will say the sorry to everyone, because we have given the time slot, but still we couldn't take the class. So it is our mistake, but I am saying the sorry first, and we are going to start with the new lesson, that is chemical bond. So first and foremost, we need to know what is the meaning of this particular chapter, that is chemical bond. So as you know, chemical, as a chemist, we need to know what is chemical. So there is a misconception that the chemical means that is not at all good, and even that is very harmful to the person. But we need to understand the thing as the chemical means mainly two types. So there will be good chemical as well as bad chemicals. So what are good chemical and what are bad chemical? I can ask you a simple question. Water. Water, is it a chemical or non-chemical? Just give me a comment. Water, is it a good chemical or bad chemical? Okay. Water, is it a good chemical or bad chemical? Okay, very good. And I want to ask one more question. Is it a water is a chemical or a non-chemical? Tell me answer. Is it a water chemical or non-chemical? Because we have a normal thought in our mind. If it is a chemical, we will not eat, and we will say that it is a toxic. For example, we people usually have food from the outside, isn't it? In the roadside, we usually eat the food, street food, and most of them usually says it is not good. And why? Because most of them usually says they are chemicals, they are adding so much of chemicals, so many things. But here we need to have a clarity. In my class, I am going to give the clarity. What is a good chemical and what is a chemical and what is a bad chemical? We can come to the conclusion here. Water. Water actually is a chemical. And why it is called as chemical? Because in the water, we have two elements, that is, one is the hydrogen, another one is the oxygen. And here, hydrogen, two hydrogen and one oxygen, which is going to bond in a covalent bond, and that is a covalent manner, the sharing of electron, and that we are going to study in the upcoming sessions. And here we need to understand, here even water is also taken as a chemical, but we can take it as a good chemical. Because without water, can you imagine, can you able to sustain in this particular earth? It is not possible. So that's why water is a chemical, but we can say that it is a very good chemical, very good chemical. And as you know, already we know that the chemical or the water, we need to drink at least 2 liters per day, at least 2 liters per day. So here, one more thing we need to understand, so many chemicals are there in our day-to-day life. We can take some of the examples like rice. Is it a chemical? Yes, of course. So rice also taken as a chemical, but we can say that in the rice what is there? Actually it is a carbohydrate, and we usually say it is not chemical, but actually it is a chemical. Why? Because carbohydrate is made up of carbon and hydrogen, and it is a carbon based compound, and it is the organic compound, and it is also chemical. But you need to understand one thing. So all these things are chemicals, but they won't harm you. They won't harm you, your body. And but whereas it is giving you the strength, it is giving you to grow your body or growth and development. Are you understood? So here very important thing is, these chemicals are the chemicals which is giving you the strength. but we'll come to the topic, that is a chemical bonding. The next one is a bond. What is bond? So normally in our day-to-day life, we will see so much of bonding. When you think about your family, there will be family bonding. It might be a husband and wife, it might be a children and father, and it might be a children and mother, and it might be a friendship bonds. So much type of bonds. When you come to the college, there will be a one more bonding, that is called which bonding? That bond is known as which bond? It is teacher and student bond, and very important. Certainly it is very important bonding. So what is this bonding then? So I can say that, see, bonding means it is a force of attraction. It is nothing but force of attraction between two species. But most of them, even we as a chemist, we think that the chemical bond means there should be one line. We usually write one line in between two atoms. But actually there is no any line such a way that there is only the force of attraction, but we cannot show in a normal thing. So that's why we will write one line. Can we see any bonding between our friends? No. There is no any tug of war or tying a thread, but there is some sort of force of attraction. The same way you can find here also, in the case of chemical, there will be a bond that is called chemical bond. I hope you understood the introduction part of this particular chemical bonding. And here we have a complete structure, a complete lesson about chemical bonding. But I'll make it very short and sweet to understand each and every person who is watching this particular video. So we'll go to the video. So next one, the first and foremost chemical bonding. And next, it is given a particular definition. A bond results from the attraction of nuclei for electrons, all atom trying to achieve a stable octet. So this is a very small sentence, but there is a very big meaning. So what is this? So here we can say that already I have told you, there is a force of attraction between two species lead to the formation of chemical bonding. And why this bonding happened? I can give you a best example. When you enter into the college, for example, if you are coming to the XLPU college, so when you come to this particular college, the first and foremost, you will not have any friends. And the first day one, you will be alone. And that time you are unstable. Okay, you are unstable. But the thing, what happened? We are there as a teachers, we are there as a lecturers, we are there as a well-wishers. We are going to give a particular motivation to you, and along with that you will make a bond with some other student, and that bond will make you stable. It will make you stable. So same way, such a way that your atoms and the molecules also require its own stability. To get the stability, what they will do, they will make a bond between the two atoms. So this is called a chemical bond, and in that you can find one particular, this is called stable octet. So most of them you might know what is octet configuration. So already you have studied in your 9th standard, there was called a word octet and even duplet. So duplet configuration is nothing but the outermost orbital, or the outermost the shell or the orbit, which should contains a 2 electron to complete its duplet configuration. And this duplet configuration will not be allowed to all the elements. It's only allowed only the few elements. For example, if you take hydrogen, if you take a helium, it can be allowed, but other elements it cannot be allowed. But when you think about the higher elements, there you need to understand at the outermost orbital, minimum of 8 electrons should be present. When the minimum of 8 electrons are present, then only you can see that stability. So that stability is known as this octet configuration. I can give you a best example is helium. After helium, neon comes. So in the neon you will find what? Octet configuration. So in the neon you have a 2 electron in the s orbital or the k shell, and you have a 8 electron in the next orbit, that is called L, KL. That also we are going to see later. And I think actually you have seen this particular KLMN and SPDF in your 9th standard, the structure of atom. But I will give you the information, don't worry about this. So I am here to give you each and every information about this. And here, come back to the topic, the octet configuration. So what is octet configuration? Outermost orbital, if you find the 8 electrons, that particular atom is completely filled, and those atoms are what we can say it is the stable atoms. So to get the stability, what we have to do? Mainly the electrons, mainly the people are electrons. These electrons are transferring. Some of the places electrons are sharing. In some of the places electrons are donating. So many things are happening. For example, I can give you a best example in your life. Some students or some friends you have, they will share everything. For example, if the friends, if they are bringing any food from your home, what you are going to do? You are going to share your food, isn't it? So you will bring something and that person will bring something and you are going to share and you will have a food, and there is the stability. And sometimes what happen, if you are going outside, if you are going for any something trip or something, there also you will share your money. There also you can see the mutual sharing. And this type of sharing called the covalent bond that we are going to see later. And some people are there, like friends are there. They always take, they won't give. They always take, they won't give. So those type of bonding, that is nothing but your ionic bonding. Here the complete transfer of electron will take place from one atom to another atom, lead to the formation of chemical bonding, and this type of chemical bonding is known as the ionic bonding. And here ionic bonding is a very, very important thing, because each and every ionic compound, it consists of this ionic bond. Example, when you take the example of your kitchen salt, at least salt, okay, salt contains what? The ionic bond. Here in the salt you have sodium and also chlorine. So those examples and what we can say extra thing you are going to see, or the extra information you are going to see in the next slide. We'll see the next point. In other words, the protons, P plus means proton, in one nucleus are attracted the electrons of other atom, that is one more thing, you can take a little bit inside the what we can say extra information. This is here what happened, two atoms are there. The one of the atom which contains what? One of the atom which contains the centrally located nucleus, and that nucleus which contains the proton as well as neutrons. What is contained? Proton and the neutron. And both proton and neutron together is known as one name. Can you name that in the comment section? What we usually call as proton and the neutron together, which is present in the nucleus. What we are calling that one? Okay. Both proton and neutron, both are present inside the nucleus, and actually it is not coming from your this one. That mass number, you will get the mass number, correct? But the thing is, one more name is there. Both proton and neutron together, which is present inside the nucleus, is having one name. What is that name? Mass number. That is right. Mass number is nothing but proton plus neutron is equal to mass number. Yes. Very good, very good, very good. Some of them already given the name called Hemant. Very good. Nucleons. Very good. Monisha. Nucleons. Very good. So nucleons. So many people they have given answer. See, really, I am appreciate each and everyone watching this video. Why? Because see, most of the time, the last week also I have taken one class. So really, I can appreciate each and everyone participating in this particular class. So nowadays, as normally there was a meeting in our what we can say department. So that time so many people they said, so online class ge yaar bartare, online class ge yaru nodtare anta. But I am really proud to say, in Excel PU College we have started this year this Excel Connect, but we can see at a time in around 600 students are online. So this is a really achievement, and also we are appreciate each and everyone those who are watching this video. Okay, we'll go to the topic. So here the next one. Next one, the two major types of bonding, which are they? That is ionic bonding and covalent bonding. So what is an ionic bonding? So here ionic bonding forms ionic compound and transfer of electrons. What is this? So already I have told you, some friends are there. So those friends, like one person always giving, another person always eating. The another person always eating, but he is not giving at all. But there is a one bonding between those people, and he is understanding, he won't give, but still he will give the, what we can say, food. The same thing happen here also. In the case of ionic bond, one of the element always gives and another element always takes. Example here, NaCl, sodium chloride. So when it is a sodium chloride, what is happening? The sodium is a metal and the chlorine is a non-metal. As you know already, you have studied already. So covalent ionic bond always form between the two atoms, and the two atoms should be, one is metal, one should be non-metal. Why? Because metal is a electropositive and non-metal is a electronegative. So non-metal is a electronegative, metal is electropositive, and because of that the metal is able to give the electron. It is ready to donate the electron. So because of that we usually call this metal as a cation. It's called as cation, and we usually write that is metal as a plus, Na plus. And non-metal, that is a chlorine, it is always ready to accept the electron, and we usually write Cl minus. So what is a Cl minus means? It is ready to accept the electrons. So this is very important. We need to understand how this ionic bond is formed. Ionic bond is formed between two species. There one should be electropositive, another should be electronegative. So electronegative should be always your non-metal, and electropositive should be always metals. So here the best example is NaCl. So you can see here complete transfer of electron. So you have so many other examples. Can you name some other example for ionic bonding or ionic compounds? Ionic compounds. Just comment me some other compounds which have ionic bonds. Ionic bond. Very good. So this is really appreciated. So NaCl already I have told. Some other compound, ionic compounds. MgCl2, very good, MgCl2. Then barium chloride, very good. Okay, so many answers. I'm really appreciate each and every one, because when I'm asking question, you are going to give the answer very soon. So I hope because of this particular class you are going to get some sort of a good knowledge, and also I know you people are really intelligent and we are ready to accept and ready to what we can welcome you to our Excel PU college, because the Excel PU college always hunt only the best. So and also we usually, if we get any student with the lower marks, so we usually get some of the lower mark students, but we will not deny those people. Why? Because we have started this institution not only for the person who is taking a good marks. We have started this institution the person who is not having a good marks, but we are ready to give that particular capability or capacity to increase his mark or her mark in our institution. And we have a particular team of teachers. They are ready to do whatever things you want, and ready to give the knowledge whatever things you want. For example, some students, I can give one best example. One of the student in the last year, he got 44% in 10th standard. But here we have a very good chairman, Suman sir. He given the opportunity to give that particular person as an admission in our institution. But you need to understand one thing. After coming here, he have taken very good marks. You cannot believe he got around 89% in his this particular second year PU examination. So this is not simple story, it is a reality. It is not the real, it is a reality what happened in our Excel. Come back to the topic. So next one is a covalent bonding. So what is a covalent bonding? Covalent bonding is nothing but the sharing of electron. Already I have told you, sharing of electron takes place between two species, lead to the formation of new bond, and that is a mutual sharing of electron and lead to the formation of molecules. For example, if you take H, that is what is H? Hydrogen atom. One hydrogen atom having one electron, another hydrogen atom having one more electron, and both are needed one more electron to become stable, to complete its duplet configuration. So here, to complete the duplet configuration, they need what? One electron. Both hydrogen atom, they are going to share each electron, and they are going to become a molecule, that is H2. So H, two hydrogen atom sharing two electrons, and they are become a molecule that is called hydrogen molecule. We'll see the next one. Next one you can see here, that is a metallic bond. So what is metallic bond? So many people, normally when we are in a high school, we have some sort of a question, or we are not having a clear idea what actually the metallic bonding is. So normally you can take a metal. For example, this is a metal. Just imagine this is a metal, and metal has a capacity to, what we can say, it is having a lustrous property. What is the lustrous property? We know that the shining property. And we know the next one, we have another property, that is a malleability. So malleability means we can beat this into thin sheets, very thin sheets. Very, very thin means you can have some of the sweets also nowadays. You will have a gold foil onto the sweet and you can eat. But it is so expensive. I cannot afford that much. But still, we can see that much, what we can say, very, 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 very thin sheets. And third one, what is that? We can draw into a very thin wire. Okay, very thin wire. So here we can see the ornaments. That is also one more property of a metal. And one more is sonorous. If you bang, you will find some sort of a sound. So that is the another property. And why I am telling all these things? So you can just imagine a metallic bond is such a way that, just imagine a particular metal sheet is there. In that sheet, there will be some portion, some small portion is there. In that portion, there will be some sort of atoms, some sort of an atoms. I'm going to zoom it. So that atom you can see in a 3D structure. There you will find 2 or 3 things, which and all. Centrally located nucleus, which consists of a neutron and the proton. What is there? Neutron and the proton. And the electron, negatively charged particle electron, which is revolving around the nucleus. So this is a normal structure of an atom. Like this, so many atoms are connected one another. Why? Because it is a solid. Because it is solid, because these atoms are connected each other. And here, one atom having a electron and also centrally located protons and the neutrons. And proton is positive charge. What actually happening? The proton or the nucleus of one atom is attracting the electron of the other atom. I repeat, protons or the centrally located nucleus, that is a positive charged particle, that is attracting the electrons of the other atom which is having a negative charge. So there is a force of attraction between them. The same way, the proton of other atom which is attracting the electron of this atom. So there will be a crossover of the attraction that lead to the formation of this particular bonding. So like that, there will be different layers. In between you can find what? Electrons, like a bread and jam. You can take a best example. Take a bread, and to that you are going to put the jam, and one more bread you are going to keep. So this is continuously happening like this. So this type of bonding you can find in the case of metals, and this is called what? Metallic bond, and this is a very strong bond. And you can ask me a question. So normally the metals, like if you take a ferrous or iron, very strong. But when you think about mercury, what about mercury, sir? So in the mercury you can see it is in the liquid form. So in that some exceptions will be there. So that we are going to learn in our, when you come to our institution, we will give you the pin to pin information about each and everything, because we are giving the IIT. So we are giving the IIT knowledge. So because of that, the each and everything you should know. When you know each and everything, you can able to what we can say, crack any competitive question. Why? Because so most of the people, they usually say, sir ಯಾಕೆ ಬೇಕು ಸರ್ ಇದೆಲ್ಲ ಈ ಬೇಸಿಕ್ಸ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡು ಏನು ಮಾಡೋದು ಅಂತ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಮೇನಾಗಿ ಗೊತ್ತಿರಬೇಕಾದ ಒಂದು ವಿಷಯ ಮಕ್ಕಳೇ, ಬೇಸಿಕ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಗೊತ್ತಿದ್ರೆ ನಿಮಗೆ ಅಡ್ವಾನ್ಸ್ ಥಿಂಗ್ಸ್ಗಳು ಏನು ಮಾಡ್ಬೋದು, ಈಸಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೋದು. ಬಟ್ ಬೇಸಿಕ್ ಥಿಂಗ್ಸ್ ಕರೆಕ್ಟ್ ಗೊತ್ತಿಲ್ಲದ್ರೆ ಅಡ್ವಾನ್ಸ್ ಥಿಂಗ್ಸ್ ಏನೋ ಈಸಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಈಗ ನಮಗೆ ಒಂದು ಬಿಲ್ಡಿಂಗ್ ಕಟ್ಟುವಾಗ ಅದರ ಪೈಲಿಂಗ್ ಅಂತ ಮಾಡ್ತಾರೆ. ಸೊ ಪೈಲಿಂಗ್ ಮಾಡುವಾಗ ಎಷ್ಟು ದೊಡ್ಡ ಬಿಲ್ಡಿಂಗ್ ನಾನು ಕಟ್ತಿದ್ದೇನೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ಬುರ್ಜ್ ಖಲೀಫಾ ಕಟ್ಟಿದ್ದಾರೆ. ಈ ಬುರ್ಜ್ ಖಲೀಫಾ ಕಟ್ಟಲಿಕ್ಕೆ ಅದರ ಪೈಲಿಂಗ್ ಎಷ್ಟು ಮಾಡಿದ್ರೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ, ಅದು ದೊಡ್ಡ ಲೆವೆಲಲ್ಲಿ ಮಾಡಿರಬೇಕು. ಯಾಕಂದರೆ ಅದರ ಹೈಟ್ ಎಷ್ಟಿದೆ ಅಂದರೆ 150 ಫ್ಲೋರ್ ಇದೆ. ಈ 150 ಫ್ಲೋರಿಗೆ ಅದು ಕರೆಕ್ಟಾಗಿ ನಿಲ್ಲಬೇಕು ಅಂದರೆ ಪೈಲಿಂಗ್ ಏನಾಗಿರಬೇಕು, ಅಷ್ಟೇ ಸ್ಟ್ರಾಂಗ್ ಇರಬೇಕು. ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಕೂಡ ಇಲ್ಲಿ ನಮ್ಮ ಎಕ್ಸೆಲಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಂದರೆ, ಈಗ ನೀವು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಸಿ ಇ ಟಿ ಎಕ್ಸಾಮ್ ಬರೀಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ರೆ, ಆ ಸಿ ಇ ಟಿ ಎಕ್ಸಾಮಿಗೆ ಬೇಕಾದಂಥದ್ದು ಪೈಲಿಂಗ್ ಮೀನ್ಸ್ ಆ ಸಿ ಇ ಟಿ ಎಕ್ಸಾಮಿಗೆ ಬೇಕಾದಂಥ ಆ ಡೆಪ್ತ್ ನಾಲೆಜ್ ಎಷ್ಟು ಬೇಕು ಅದನ್ನು ನಾವು ಇಂಚಿಂಚಾಗಿ ಒಂದೊಂದು ಸ್ಪಾಟಲ್ಲಿ ಕೂಡ ನಾವು ಕೊಟ್ಕೊಂಡು ಹೋಗ್ತೀವಿ. ಈವನ್ ಕ್ಲಾಸಲ್ಲಿ ಲೆಕ್ಚರರ್ಸ್ ಏನು ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ, ಆ್ಯಸ್ ಯು ನೋ ಇಟ್ ಇಸ್ ಅ ಇಂಟಿಗ್ರೇಟೆಡ್ ಕಾಲೇಜ್, ಒಂದು ಯಾವುದೇ ಟಾಪಿಕನ್ನು ಮಾತಾಡ್ತಾ ಇರಬೇಕಾದ್ರೆ ಅದರಲ್ಲಿ ನಾವು ಬೋರ್ಡ್ಸಿಗೆ ಯಾವ್ದು ಬರ್ತದೆ, ಸಿ ಇ ಟಿಗೆ ಯಾವ್ದು ಬರ್ತದೆ, ನೀಟಿಗೆ ಯಾವ್ದು ಬರುತ್ತೆ, ಜೆ ಇಗೆ ಯಾವ್ದು ಬರುತ್ತೆ ಅಂತ ಸಪ್ರೇಟಾಗಿ ಹೇಳಲಿಕ್ಕೆ ಹೋಗ್ತೀವಿ. ಐ ಡೋಂಟ್ ನೋ these things are happening in other college or institution, I don't know, but the thing this is I am seeing in our institution, because each and every class we are monitoring. So you can see that each and every class is monitoring and each and every students also monitoring in our institution, so lead to the formation of a very good result. ನೀವು ಕೇಳ್ತಾ ಇರ್ಬೋದು, ಒಳ್ಳೆ ರಿಸಲ್ಟ್ ಕೊಡ್ತಾ ಇದೆ ಎಕ್ಸೆಲ್, ಯಾಕೆ ಕೊಡ್ತಾ ಇದೆ, ಹೇಗೆ ಕೊಡ್ತಾ ಇದೆ ಅಂತ. ಅದು ಕೊಡ್ತಾರೆ ಅಂತ ಹೇಳುವಂಥದ್ದು ಈಸಿ ಅಲ್ಲ ಮಕ್ಕಳು. ಇಲ್ಲಿ ಏನಂತ ಹೇಳಿದರೆ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಸ್ಟೆಪ್ ಕೂಡ ನಾವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ಅನಾಲಿಸಿಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲಿ ಒಂದು ಸ್ಟೂಡೆಂಟ್ ನಮ್ಮ ಇನ್ಸ್ಟಿಟ್ಯೂಟಲ್ಲಿ ಹತ್ತಿದ ಅಂತ ಹೇಳಿದರೆ ಅವನ ಫುಲ್ ಡಾಟಾ ನಮ್ಮ ಆ್ಯಪಲ್ಲಿ ಇರ್ತದೆ. ಸೊ ಅವನ ಆ್ಯಪಲ್ಲಿ ಅವನ ಒಂದೊಂದು ದಿನದ ಚಟುವಟಿಕೆಗಳು, ಅವನಲ್ಲಿ ಒಂದೊಂದು ದಿನದ ಎಕ್ಸಾಮಿದು ಮಾರ್ಕ್ ಕೂಡ ಅದರಲ್ಲಿ ಅಪ್ಲೋಡ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಸೊ ಅಪ್ಲೋಡ್ ಆದ ಮಾರ್ಕನ್ನು ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ಗ್ರಾಫಿಕಲಿ ನೋಡ್ಬೋದು, ಅವ್ನು ಜಾಸ್ತಿ ಮಾರ್ಕ್ ತೆಗಿತಿದ್ದಾನ ಇಲ್ಲ ಡೌನ್ ಆಗ್ತಾ ಇದ್ದಾನ ಅಂತ. ಡೌನ್ ಆಗ್ತಾ ಇದ್ದರೆ ಕೌನ್ಸಿಲರ್ಸ್ ಇದ್ದಾರೆ, ಅಕಾಡೆಮಿಕ್ ಕೌನ್ಸಿಲರ್ಸ್ ಇದ್ದಾರೆ, ಫುಲ್ಲಿ ಏನಂತಾರೆ ಟ್ರೈನ್ಡ್ ಲೆಕ್ಚರರ್ಸ್ ಇದ್ದಾರೆ, ಅವ್ರ ಹತ್ರ ಅವರನ್ನು ಕಳಿಸ್ತಾರೆ. ಅವರ ಪ್ರಾಬ್ಲಮ್ ಏನಂತ ಹೇಳಿದ ಕೂಡಲೇ ಅದಕ್ಕೆ ಬೇಕಾದ ಸೊಲ್ಯೂಷನ್ ಕೊಡ್ತಾರೆ. ವಿದಿನ್ 1 or 2 ಎಕ್ಸಾಮ್ ಹಿ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಸೇಮ್ ಪೇಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಎಕ್ಸೆಲ್. ಓಕೆ, ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಟಾಪಿಕ್. ಸೊ ಇಲ್ಲಿ ಮೆಟಾಲಿಕ್ ಬಾಂಡಿಂಗ್ ಗೊತ್ತಾಯಿತು. ಸೊ ಮೆಟಾಲಿಕ್ ಬಾಂಡಿಂಗ್ ಗೊತ್ತಾಯಿತು, ಅದರೊಟ್ಟಿಗೆ ನಾವು ಮೆಟಲಿದ್ದು ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ಏನು ಕ್ಯಾರೆಕ್ಟರ್ ಕೂಡ ಕಲ್ತ್ವಿ. ಇಲ್ಲಿ one more character we have to see, that is it is having a high what we can say melting point. So it is, see, when you think about a metal, if you keep that metal on the fire it will not burn. Why? Because its melting point is very high. But the same way, if you take a paper and if you keep it on the fire it will burn very fast. Why? Because it is not a metal. Understood? We'll see the next one. So just now what I've said, the same thing happens here. Mobile electrons. ಸೊ ಇಲ್ಲಿ ಮೊಬೈಲ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳು ಇರ್ತದೆ. ಈ ಮೆಟಲ್ಸ್ನ ಮಿಡ್ಲಲ್ಲಿರುವಂಥ ಈ ಮೊಬೈಲ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳು ಏನು ಮಾಡ್ತದೆ ಅಂದರೆ ಅದಕ್ಕೆ ಕನೆಕ್ಟ್ ಆಗಿರ್ತದೆ. ಈಗ ಇನ್ನೊಂದು ಕೇಳ್ಬೋದು, ಸರ್ ನಾವೊಂದು ಪ್ಲಾಸ್ಟಿಕನ್ನು ತೆಗೆದು ಯಾವುದಾದ್ರೂ ಏನಂತಾರೆ ಇಲೆಕ್ಟ್ರಿಸಿಟಿ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ಅಲ್ಲಿ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳು ಮೂವ್ ಆಗಲ್ಲ ಅಂತೇಳಿ. ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಯಾಕೆ ಮೂವ್ ಆಗಲ್ಲ ಅಂದರೆ ಅದರಲ್ಲಿ ಏನಿಲ್ಲ, ಫ್ರೀ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲ. But when you think about the metal, you have a free electron. Because of that, when you keep the positive or negative charge onto this, whatever the free electrons are there, they are ready to move. Are you understood? They are ready to move. I hope you have studied this in your physics purely. It is not actually your chemistry. It is a purely physics. But you have to know the chemistry behind this also. Okay? We'll see the next one. So next one, ionic bonding. Electrons are transferred between valence shell of atom and ionic compounds are made of ions. So ಇದೆಲ್ಲ ನಾನು ಒಂದೊಂದಾಗಿ ಹೇಳ್ಕೊಂಡು ಬರ್ತೇನೆ. ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಸಿಂಪಲ್ ಆಗಿ ನೋಡ್ಲಿಕ್ಕೆ ಹೋಗುತ್ತಿದ್ರೆ ನಮಗೊಂದು ಅಯಾನಿಕ್ ಬಾಂಡ್ ಆಗಬೇಕು, ಯಾವುದೇ ಒಂದು ಬಾಂಡ್ ಆಗಬೇಕಾದ್ರೆ ನಮಗೆ ಮೇನ್ ಆಗಿರುವಂಥ ಒಂದು ವಿಷಯ ಅಂತ ಹೇಳುವಂಥದ್ದು ಯಾವುದು, ನಮಗೆ ಮೇನ್ ಆಗಿರುವುದು ಇಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ಗಳು ಏನಾಗ್ತಾ ಇದೆ, ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ಗಳು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಇಲೆಕ್ಟ್ರಾನ್ಗಳು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿ ಇದ್ದರೆ ಎಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇದೆ, ಯಾವುದಕ್ಕೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇದೆ, ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇದೆ ಅದೆಲ್ಲ ನಮ್ಗೆ ಗೊತ್ತಿರಬೇಕಾಗುತ್ತೆ. ಐ ವಿಲ್ ಟೆಲ್ ಯು ಇನ್ ಡೀಟೇಲ್. So when you think about an atom, why? Because see, I am talking too much of the atom. Why? Because atom is connected to this bonding. Here in the case of atom, the electrons are there and these electrons are revolving around the nucleus called what? The orbits or the orbitals. And we have two things, that is orbit means KLMN and orbitals means SPDF. And these electrons are revolving around the nucleus and these orbits are named. How? The orbit which is in the outermost of the atom, that is called a ultimate shell. It is known as ultimate shell and it is denoted by N, and also that ultimate shell is also named by one more name, that is called valence shell. What is that? Valence shell. So this valence shell contains some of the electron. What type of electron? These electrons are known as what? Can you able to name? The valence shell contains the electron, those the electrons have its own name, what is the name of that particular electrons? So already given the answer, really I am appreciated each and every one. So valence electrons, the electron which is present in the valence shell is a valence electron. But I want to ask one more question. The other than valence electron which is present in the atom, that is known as, other than valence electron, the electron which is present inside that particular atom in other orbits, they are known as what? Can you name the electrons other than the valence electron present in the atom, which is not take part in the chemical bonding or not take part in the sharing of electrons? That electron is known as. Can you able to name that particular electrons? Yeah, somebody given answer electron, not it is electron, orbital electrons, no. So you are trying really good. See, ಅದೊಂದು ವಿಷಯ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ, ಒಬ್ಬೊಬ್ರು ಏನೂ ಮಾಡಲಿಕ್ಕೆ ರೆಡಿ ಇರೋದಿಲ್ಲ, ಯಾವುದಕ್ಕೂ ಇದ್ರ ಕುಂಟು ನಾವೇ ಹೇಳ್ಕೊಂಡಿರ್ತಾರೆ, ನಮ್ಮಿಂದ ಆಗಲ್ಲ, ಅದೆಲ್ಲ ದೊಡ್ಡವರು ಮಾತ್ರ ಮಾಡೋದು, ನಮಗೆ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ ಅಂತ. ಐ ಆಮ್ ರಿಯಲಿ ಅಪ್ರಿಷಿಯೇಟ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಒನ್. ಸಿ, ಯು ಆರ್ ಟ್ರೈಯಿಂಗ್ ಸಮಥಿಂಗ್. ಸೊ ಇಫ್ ಯು ಆರ್ ಟ್ರೈಯಿಂಗ್ ಸಮಥಿಂಗ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಸಮಥಿಂಗ್, otherwise you will not get anything. Are you understood? So this is a very very good what we can say initiative. You should try something. See, so many people they have given celestial body, free electrons, orbital electrons, so many things you have given, but I am going to give the what is the name of that electron. So those electrons are known as core electron. Keep it in your mind. Those electrons are known as core electrons, CORE. So you can ಆಸ್ಕ್ ಮೈ ಕ್ವೆಶನ್, ಸರ್ ಯಾಕೆ ಸರ್ ಬೋರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂತ. ಸೊ ಆಲ್ರೆಡಿ ನಾನು ಪಿ ಪಿ ಟಿ ಹಾಕಿದ್ದೀನಿ. ಈ ಪಿ ಪಿ ಟಿ ಹಾಕಿರುವಾಗ ನಾನು ಇದನ್ನು ಬರೀಲಿಕ್ಕೆ ಹೋದರೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಈ ಪಿ ಪಿ ಟಿ ಆಚೆ ಈಚೆ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ, ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಬರೀತಾ ಇಲ್ಲ. ಡೋಂಟ್ ಫೀಲ್ ಬ್ಯಾಡ್. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಅಂದರೆ ಇಲೆಕ್ಟ್ರಾನ್ಗಳು. ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಟಾಪಿಕ್. ಸೊ ಹಿಯರ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ದೇರ್. ಒನ್ ಈಸ್ the electron which is present in the valence shell, they are known as valence electron, and the electron other than valence electron which is present inside the orbits, they are known as core electrons. But you should know one more thing. The valence electrons are responsible for the formation of bonding and also chemical reactions. Very very important. And here these valence electrons also categorized into two types. Valence electrons also categorized into two types. That you are going to study under chemical bonding only. That is called, one is a lone pair of electron, another one is bond pair of electrons. What are they? Lone pair of electron and a bond pair of electrons. What are these lone pair and bond pair of electrons? And here you can see lone pair of electrons are the electron which are present in the orbit, but they are not take part in the bond formation. They are known as lone pair of electron, and we usually represent these lone pair of electron in the form of LP. And the same way we have a BP. What is BP? Bond pair of electrons. Those bond pair of electrons are the electron which take part in the bond formation. They are take part in the bond formation. I repeat once again, there are mainly two types of electron. One is a valence electron, another one is core electron. Valence electron present in the valence shell, and the core electron which is present inside the valence orbital, that is nothing but it is a core of this particular atom. And the next one, what is that? Next one is the valence electron. In the valence electron we have a two types or two category. One is a bond pair of electron, another one is lone pair of electrons. So bond pair of electrons are the electron which take part in the bond formation, and lone pair of electron take part in the student. 1 minute, I will come back. Hi students, sorry for the interruption. Okay, come back to the topic. So already I've told you ionic bonding. Already the two types of electrons we are discussing. Those electrons, which are the main thing, that is the lone pair of electron and bond pair of electrons. See here, lone pair of electrons are the electron which is present in the valence shell, but they are not take part in the bond formation. But here bond pair of electrons are the electron which take part in the bond formation. For example, if you take water molecule, in the case of water molecule, two hydrogens are connected to the single oxygen, and here we usually write in the bent structure. Why? Because in the case of oxygen we have a lone pairs, two lone pairs, we will write like a Mickey Mouse, isn't it? So two electrons or the two pairs of electron we will write. So those electrons of the oxygen which will not take part in the bond formation, but here down you can find the oxygen is connected to the two hydrogen, so that is called the bond pair of electron. I repeat, bond pair of electrons are the electron which take part in the bond formation, and the lone pair of electrons are the electron which is not take part in the bond formation, but they will be present in the valence shell itself. Come back to the topic. So here already you understood transfer of electron lead to the formation of ionic bonding here. So here it is ionic bond lead to the formation of what? Ionic compound. You can see mainly the salt or the crystals. Mainly these ionic compounds are formed the crystals, or it is also called as salt. For example, if you take NaCl, sodium chloride is the best example for the salt. And here then ionic bond, already I have told you the briefly what it is. I am going to give you the detail information. Already I have told you, ನಾನು ಆಗಲೇ ಹೇಳಿದ್ದೆ, ನಾನು ಬ್ರೀಫಾಗಿ ಎಲ್ಲವನ್ನು ಹೇಳ್ಕೊಂಡು ಹೋದೆ. ಈಗ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ, ಒಂದೊಂದನ್ನೇ ಸಪ್ರೇಟ್ ಆಗಿ ಹೇಳ್ಕೊಂಡು ಹೋಗ್ತಿದ್ದೀನಿ. ಅಯೋನಿಕ್ ಬಾಂಡಿಂಗ್ ಅಲ್ಲಿ ಆಲ್ವೇಸ್ ಫಾರ್ಮ್ ಬಿಟ್ವೀನ್ ದ ಮೆಟಲ್ ಆ್ಯಂಡ್ ನಾನ್ ಮೆಟಲ್. ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಮೆಟಲ್ ಅಂದರೆ ಏನು, ದೇ ಆರ್ ರೆಡಿ ಟು ಲೂಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. Hello? Is it audible? So somebody is crying there. Aditya Sardar, don't cry, man. It's because of some sort of a technical issue. Don't worry, I am back. Okay. Is it audible? Yes, thank you. So we'll come to the topic once again. So here already I've told you ionic bonding always form between the metals and non-metals. And here metal you can see the plus charge, and non-metal you can find negative charge. So metal is always ready to give the electron, and electron rich species. Yavado metal anta heluvanthadu electron rich species, and they are ready to give the electron. When they given the electron, what happen? It will get the stable electron configuration. For example, if it is sodium chloride. Sodium, what is the atomic number of sodium? 11. So what is the atomic number of sodium? 11. So outermost orbital you have a 1 electron, means 2, 8, 1. So that 1 electron, it is given to chlorine, which is having a lack of 1 electron. So that time what happened? It is ready to accept 1 electron. Which one? Chlorine. And lead to the formation of ionic bond. So here always metals are electron donors and non-metals are electron acceptors. Metals are electron donors and non-metals are electron acceptors. So here when the electron donors, when they are giving electron, we will get positive charge. And when the electrons are accepting by the non-metal, that time you will get what? You are going to get which one? Thus is called, mainly we are going to see the non-metal that is ready to accept the electron. When they accept the electron, it is going to get the negative charge. ನಿಮಗೆ ಒಂದು ವಿಷಯ, ಸಣ್ಣ ಒಂದು ವಿಷಯ ನೋಡಬೇಕು. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಮೇನ್ ಆಗಿ ನಾವು ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ನಾವು ಕಲಿಯುವಾಗ ವಿ ಆರ್ ಸೀಯಿಂಗ್ ಒನ್ ಥಿಂಗ್. ವೆನ್ ವಿ ಆರ್ ಗಿವಿಂಗ್ ಸಮಥಿಂಗ್, we are going to increase, so we are going to lose something. But here when metal is giving 1 electron, it is getting the positive charge, but non-metal gaining 1 electron, that getting the negative charge. Here why it is happening like that? Because electrons are transferring. So electrons are negatively charged particle. When it is a negatively charged particle, they are, when it is added up in the non-metal, it is electron density increases. So that's why it is having a negative charge. And the metals are electron donor, the electron density decreases. So that time the positive charge will come. So because of that, best example is Na plus and Cl minus. Na plus and Cl minus. We'll see the next one. Next one you can see here. Electronegativity difference. So what is electronegativity difference? Before that we need to know what is electronegativity. Electronegativity andre ಏನು ಮಕ್ಕಳೇ? It is very important thing we need to understand here. Electronegativity is nothing but when the electrons, the pair of electron or the element which is shared with the another electron or another atom, there will be shared pair of electron. This element has a capacity to pull those shared pair of electron towards itself. That is called electronegativity of the atom. So what is the electronegativity of the atom? The electronegativity is nothing but it is the capacity of the element to what we can say grab the electron, shared pair of electron towards itself. So in this case what happened? You can see here the electronegativity difference should be 2.1. So here look up in the case of NaCl and CaCl2. So both the things are ionic compounds. And here the compound with the polyatomic ions, for example you can see here, what is the meaning of polyatomic and diatomic? That also you need to understand. So these are called diatomic molecules, mean in a molecule you will find 2 different types of atom, but in this case you will find 3 different types of atom, which are the here sodium and chlorine. Here you have calcium and chlorine, but the thing is here if you come, sodium is there, nitrogen is there and oxygen is there, and this is considered as a what is that? Polyatomic molecule. I hope you understood. So next one. The best example already I have told you, sodium chloride. Here the sodium which is having a 2 electron in the inside, 8 and 1 electron, and here in the case of chlorine, outermost orbital you have only 7 electron. When it gives this 1 electron to this particular what we can say chlorine, it becomes 8 in the outside, and here also it becomes 8 outside. So that time Na becomes Na plus, Cl becomes Cl minus. So it both are become stable, lead to the formation of ionic compound, and the bond between these two, sodium and chlorine, that is called ionic bond. And here the structure will be like this. So when you see the, what we can say, X-ray diffraction method, if you see, you will find this type of a structure. In that, the blue color it is showing that is a anion, and the pink color it is showing that is cation. So this is a cluster of what you can say, it is also known as lattice. Okay, so this is called the lattice because in the crystal you will have the crystal lattice. So that you are going to study later in the upcoming slides. And the next one, very important, that is the properties of ionic compounds. As you know, the mainly the ionic compounds are salts or the crystals. Already I have explained you. And here all these ionic compounds are very hard solids. Most of them are very hard solids, and even some sort of a solid will be what we can say a hard solid at 22 degrees Celsius. Very hard. But when the temperature changes, the hardness of that particular ionic solid might be changes. Okay. So next one, high melting point temperature. So melting point will be very high. Why? Because already you know that it is a crystal. The melting point will be very high. Next one, non-conductor of electricity in a solid phase. So they are non-conductor of electricity during the solid state. For example, it is a crystal. So this is when it is in the crystal form. As you know, it is in the solid form. So electrons are not moving because what happened, mainly here we need to have what we can say ions. When this particular ionic compound I am going to put into water, what is going to happen? This particular ionic compound dissociated into ions, that is a Na. For example, if you take a sodium chloride crystal, it is Na plus Cl minus. When the ions are formed, there will be a movement of what we can say, these ions lead to the what we can say, lead to the formation of what we can say movement of electrons, lead to the conduction of what electricity. But in the case of mainly in the case of the solid state, there will not be what we can say, electricity will not be moved. Why? Because the electrons or the ions will not be there in the free form. But when is there in the form of the liquid form, it is a very good conductor of electricity. Example, I can give you a best example when it was in the case of mainly 3 Idiot movie. So when you think about the 3 Idiot movie, in that we can see the first scene in that Chatur Ramalingam, and so many people were there in the one hostel, and there was some sort of a problem happened, and a new person came, and he is a Pungshik Wangdu, and he is the main person. He entered, and he is a very genius, and some people they are doing some sort of what we can say, ragging. So that time what happened, he any one of the person, he is going to do susu there. So what he did, he took one spoon, that is a metal spoon, and he connected that metal spoon into what is that, to the electric socket, and he switched on. And you know what will going to happen, because normally we know that our urine which contains what, sodium chloride, but it is there in the form of a liquid form. So that time you will catch what we can say, there should be a electricity passage. What is going to happen, understand. So this is the best example we can understand and we can memorize. Why? Because when we are memorizing some of the funny fact, we will not forget those things. That's why I'm telling this. Okay, come back to the topic. So next one here, good conductor in the liquid state, that already I've explained you. The properties of molecular. Next comes covalent bonding. So here we end up with the ionic bonding. Next we'll move on to the next topic, that is called covalent bonding. So covalent bonding will lead to the formation of what? Molecules. Already I've told you. Hydrogen is having one electron, another hydrogen is having another electron, two atoms are coming closer and two electrons are sharing each other, mutual sharing takes place, there will be bond formation. That bond is known as covalent bond. The same way, oxygen and oxygen is sharing two electrons, lead to the formation of two bonds, and lead to the formation of two bonds, there will be a formation of oxygen molecule. In the case of hydrogen you have a single bond, in the case of oxygen you have double bond. Why? Because outermost orbital oxygen contains mainly 6 electrons. So 6 electron, it becomes 8. What is required? 2 more electron. So oxygen will share 2 electron each. So that's why you will find 2 bonds. But when you go to the nitrogen, you will have how many bonds? Mainly 3 bonds. Why? because the nitrogen atomic number is 7. Outermost orbital you will have how many electrons? 5 electrons. You require how many? 3 more electrons to complete octet configuration. So that's why in between two nitrogen atom you will have a 3 bond and lead to the formation of a stable configuration. Are you understood? So hydrogen, how many bonds are there? Single bond. In the case of oxygen, how many bonds are there? Double bond. In the case of nitrogen, how many bonds are there? Triple bond. So you can ask me a question. ಸರ್ ಇದೆಲ್ಲ ಬಾಂಡ್ಗಳು ಸೇಮಾ? ಹೌದು, ಎಲ್ಲವೂ ಕೂಡ ಏನಾಗಿರುತ್ತೆ ಮಕ್ಕಳೇ? ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಆಗಿರುತ್ತೆ. ಯಾಕೆಂದರೆ ಕೋವಲೆಂಟ್ ಬಾಂಡಿನ ಪ್ರತ್ಯೇಕತೆ ಏನಂದರೆ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಇಸ್ ಫಾರ್ಮ್ಡ್ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಬಿಕಾಸ್ ಆಫ್ ದಿ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಹಿಯರ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಹೈಡ್ರೋಜನ್ ಆಲ್ಸೋ, oxygen and even nitrogen, the electrons are shared. Electrons are shared. So we'll just see the one by one. So pair of electrons are shared between two non-metal atoms, and electronegativity, you know, it should be less, and in the case of formation of polyatomic ions. So here the summary of this particular points I can take. So in the case of ionic compound, the electronegativity should be very high, but in the case of covalent compound, electronegativity should be very low. ಸೊ ಇಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? ಅಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಇಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಕಮ್ಮಿ ಇದ್ದರೆ ಕೋವಲೆಂಟ್ ಕಾಂಪೌಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಇದು ಎಲ್ಲಿಗೆ ನಿಮ್ಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಅಂದರೆ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಮೇನ್ಲಿ ದ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್. ಓಕೆ, ವಿಲ್ ಸಿ ದ ನೆಕ್ಸ್ಟ್ ಒನ್. So in the case of properties of a molecular substance or covalent compound, as you know, correct ulta of your ionic compound, you can see here low melting point temperature and boiling point temperature, and relatively soft solid, and as compared to the ionic compound, and non-conductor of electricity in the any phase. For example, you can see here in the case of this, ಇದರಲ್ಲಿ ಮೇನಾಗಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗಿರುತ್ತೆ? ತುಂಬ ಕಮ್ಮಿ ಇರ್ತದೆ. ಯಾಕೆ? ಅವುಗಳು ಸಾಲಿಡ್ ಅಲ್ಲ, ಅವರು ಏನಾಗಿರೋದು ಕ್ರಿಸ್ಟಲ್ ಫಾರ್ಮಲ್ಲಿ ಇರಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ ನೋಡ್ಲಿಕ್ಕೆ ಹೋದರೆ ಲೋ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್, ಲೋ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇರ್ತದೆ, ಮತ್ತು ಇನ್ನೊಂದು ಸಾಫ್ಟ್ ಸಾಲಿಡ್ಗಳಾಗಿರುತ್ತದೆ. ಯಾವುದು? ಕೋವಲೆಂಟ್ ಕಂಪೌಂಡ್ಸ್. ನೆಕ್ಸ್ಟ್, ನಾನ್ ಕಂಡಕ್ಟರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. So most of the covalent compounds are non-conductor of electricity. Why? Because as you know, there is no any formation of ions. When the formation of ions takes place, there will be some sort of what? Some sort of the movement of electron will take place. But here you cannot. Understood? Example ತೆಕೊಳ್ಬೋದು. ಈಗ ಪ್ಲಾಸ್ಟಿಕ್ ತೆಕೊಳ್ಳಿ. ಈ ಪ್ಲಾಸ್ಟಿಕಲ್ಲಿ ಏನಿದೆ? ಇದು ಪಾಲಿಮರ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಈ ಪಾಲಿಮರಲ್ಲಿ ಕಾರ್ಬನ್ ಇರ್ತದೆ. ಓಕೆ, ಈ ಕಾರ್ಬನ್ ಏನಾಗಿರುತ್ತೆ? ಒಂದಕ್ಕೊಂದು ಕನೆಕ್ಟ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಕಾರ್ಬನ್ ಏನು? ನಾನ್ ಮೆಟಲ್. ಆ್ಯಂಡ್ ನಾನ್ ಮೆಟಲ್ ಆಗಿ ಅಲ್ಲಿ ಏನಿರಲ್ಲ, electron negativity difference ತುಂಬಾ ಕಮ್ಮಿ ಇರ್ತದೆ. ಲೀಡ್ ಟು ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಕೋವಲೆಂಟ್ ಬಾಂಡ್. ಆ್ಯಂಡ್ ಇಫ್ ಯು ಕನೆಕ್ಟ್ ದಿಸ್ ಟು ದಿ ಎನಿ electric wire or something, you will not find any shock here. Why? Because you will not find any ions here, and you will not find any free electrons here. So that's why you will not find any sort of a shock here. Okay, we'll see the next one. So here covalent, ionic, metallic, see bonding. So you can see so many compounds are given, and in that you can see which is a covalent, which is ionic, and which is a metallic in nature. Okay, that we can see later. We'll go to the next one. Important thing, that is a Lewis dot structure. ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಮಕ್ಕಳು, ಇದು ನಿಮಗೆ ಫಸ್ಟ್ ಪಿ ಯು ಸಿಯಲ್ಲಿ ಬರುವಂಥ ಟಾಪಿಕ್, ಅದಕ್ಕೋಸ್ಕರ ಸ್ವಲ್ಪ ಗೊತ್ತಿರಬೇಕು. ಏನಿದು ಲೆವಿಸ್ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂದರೆ? ಸೊ ಲೆವಿಸ್ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಯಾಕೆ ಇಂಪಾರ್ಟೆಂಟ್, ಯಾಕೆ ಬೇಕು ಅಂತ ಹೇಳುವಂಥದ್ದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಲೆವಿಸ್ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ ನೋಡ್ಬೋದು, ಫಸ್ಟ್ ಒನ್ ಹೈಡ್ರೋಜನ್ ಒಂದು ಡಾಟ್ ಹಾಕಿದ್ದಾರೆ. ಅದೇ ಇಲ್ಲಿ ಹೀಲಿಯಂ ನೋಡಿದರೆ 2 ಡಾಟ್ ಹಾಕಿದ್ದಾರೆ. ಲೀಥಿಯಮಲ್ಲಿ 1, ಬೆರಿಲಿಯಮಲ್ಲಿ 2, 3. ಇದೇನಂದ್ರೆ ಡಾಟ್ ಏನು ಹಾಕಿದ್ದಾರೆ ಇದರಲ್ಲಿ, ಅದು ನಮ್ಮ ಔಟರ್ಮೋಸ್ಟ್ ಆರ್ಬಿಟಲ್ ಆರ್ ವ್ಯಾಲೆನ್ಸ್ ಆರ್ಬಿಟಲಲ್ಲಿ ಇರುವಂಥ ಇಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಹಾಕಿದ್ದಾರೆ. ಇದು ಗೊತ್ತಿರೋದು ಯಾಕೆ? ಇದನ್ನು ಗೊತ್ತಿದ್ರೆ ನಮಗೆ ಬಾಂಡಿಂಗ್ ಮಾಡಲಿಕ್ಕೆ ಏನಾಗುತ್ತೆ? ಈಸಿ ಆಗ್ತದೆ. ಈಗ ಹೈಡ್ರೋಜನ್ ಒಂದು ಇಲೆಕ್ಟ್ರಾನ್ ಉಂಟಂತ ಗೊತ್ತು, ಇದನ್ನು ಯಾವುದ್ರೊಟ್ಟಿಗೆ ನಮಗೆ ಬಾಂಡಿಂಗ್ ಮಾಡ್ಬೋದು ಅಂದರೆ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ಟಿಗೆ ಬಾಂಡ್ ಮಾಡಿ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಮಾಡ್ಬೋದು. ಅದೇ ಇದನ್ನು ತಗೊಂಡು ಬಂದು ನಾವು ಕ್ಲೋರಿನ್ ಒಟ್ಟಿಗೆ ಬಾಂಡ್ ಮಾಡಿದರೆ, ಕ್ಲೋರಿನಲ್ಲಿ ಎಷ್ಟಿದೆ? 7 ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ, ಇದಕ್ಕೆ 8 ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕು. ಸೊ ಇದರ ಒಟ್ಟಿಗೆ ಮಾಡಿ ನಮ್ಗೆ ಏನು ಮಾಡ್ಬೋದು? ಹೈಡ್ರೋಕ್ಲೋರಿಕ್ ಆ್ಯಸಿಡ್ ಮಾಡ್ಬೋದು. ಅದೇ ಹೈಡ್ರೋಜನ್ ತಂದ್ಕೊಂಡು ಫ್ಲೂರಿನ್ ಒಟ್ಟಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಏನು ಮಾಡ್ಬೋದು? ಹೈಡ್ರೋಫ್ಲೂರಿಕ್ ಆ್ಯಸಿಡ್ ಮಾಡ್ಬೋದು. ಅರ್ಥ ಆಗ್ತಿದೆ? ಹೈಡ್ರೋಜನ್ ಫ್ಲೂರೈಡ್ ಮಾಡ್ಬೋದು. ಸೊ ಹೀಗೆ by looking at this particular notation, we can able to what we can say form a bond, and this particular notations are known as what is known as Lewis dot structure. So Lewis dot structure is the structure where you can find the symbol of the element, you can find the symbol of the element, and along with that you will find the outermost orbital, how many electrons are there, that will be showed. The outermost orbital, how many electrons are there, that will be showed. Okay. Okay. So we are going to conclude today's class because time is up. So before concluding something, we need to understand one thing. So we are seeing this particular platform, that is Excel PU College. So once again, so Excel PU College idilli namma Guruvayanakere place agide. ಸೊ ಇಲ್ಲಿ ನಮ್ಮ ಮೇನ್ ಆಗಿರುವಂಥದ್ದು ನಮ್ಮ ಅಡ್ಮಿಷನ್ ಪ್ರೋಸೆಸ್ ತುಂಬ ಸ್ಪೀಡಾಗಿ ಆಗ್ತಾ ಇದೆ. ಯಾರು ನಿಮ್ಮ ಮಕ್ಕಳನ್ನು ಅಡ್ಮಿಷನ್ ಮಾಡಲಿಕ್ಕೆ ಇದ್ದರೆ ಆದಷ್ಟು ಬೇಗ ಬಂದು ಅಡ್ಮಿಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಯಾಕೆಂದರೆ ಲಿಮಿಟೆಡ್ ಸೀಟ್ಗಳಿದೆ. ಆ್ಯಂಡ್ ನಮ್ಮ ಯು ಎಸ್ ಪಿ ಅಂತ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಕೂಡ ನಾನು ಹೇಳಿದ್ದೇನೆ, ಯು ಎಸ್ ಪಿ ಅಂದರೆ ಯುನೀಕ್ ಸೆಲ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳುವಂಥದ್ದು, ಅದು ಎಲ್ಲದಕ್ಕೂ ಇರುವಂಥದ್ದು. ನಮ್ಮ ಯು ಎಸ್ ಪಿ ಅಂತ ಹೇಳುವಂಥದ್ದು ಒಂದೇ, ಒಂದು ಡಿಸಿಪ್ಲಿನ್, ಇನ್ನೊಂದು ನಮ್ಮ ಅಕಾಡೆಮಿಕ್ ಅಚೀವ್ಮೆಂಟ್ಸ್. ನಾವು ಯಾರಿಗೂ ಕೂಡ ಯಾವ ರೀತಿಯಾದಂತಹ ಏನಂತೇವೆ ವಿಷಯವನ್ನು ಹೇಳಲಿಕ್ಕೆ ಹೋಗಲ್ಲ, ಯಾಕಂದರೆ ನಮ್ಮ ರಿಸಲ್ಟೇ ಮಾತಾಡ್ತಾ ಇದೆ. ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್ ಐ ನೀಡ್ ಟು ಟೆಲ್ ಯು ಹಿಯರ್, ದ ಥಿಂಗ್ ಈಸ್, ಇಫ್ ಯು ಟೇಕ್ ಯುವರ್, ಈಗ ಈ ಸ್ಪಾಟಲ್ಲಿ ತೆಗೊಳ್ಳಿ, ನಿಮ್ಮ ಮೊಬೈಲ್ ತೆಗೊಳ್ಳಿ, ಮೊಬೈಲ್ ತಗೊಂಡು ಜಸ್ಟ್ ಕರ್ನಾಟಕ ಪಿ ಯು ಇಲ್ದ್ರೆ ಬೆಸ್ಟ್ ಪಿ ಯು ಅಂತ ಹೊಡೆದ್ರೆ ಸಾಕು, ನಮ್ಮ ಕಾಲೇಜೇ ಫಸ್ಟ್ ಇರುತ್ತೆ. ಅದು ಎಲ್ಲಿ ಕೂಡ ಸಿಗಲಿಕ್ಕೆ ಚಾನ್ಸಸ್ ಇಲ್ಲ. ಮತ್ತು ಇನ್ನೊಂದಿದೆ, ನಿಮಗೆ ವಿಷಯ ಗೊತ್ತಿದೆ, ಗೂಗಲಲ್ಲಿ ನಮಗೇನು ಕೂಡ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ನಮ್ಮ ಕಾಲೇಜ್ ಫಸ್ಟ್ ಬರಬೇಕು ಅಂದರೆ. ಯಾಕೆಂದರೆ ನಮ್ಮ ಎಕ್ಸಲೆನ್ಸ್, ನಮ್ಮ ರಿಸಲ್ಟ್, ನಮ್ಮ ಈ ಒಂದು ಏನಂತಾರೆ ನಮ್ಮ ನೇಮ್ ಮತ್ತು ಫೇಮನ್ನು ತರಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡಿದೆ. ಸೊ ಅದಕ್ಕೆ ಮೇನಾಗಿ ಕಾರಣಕರ್ತರಾಗಿರುವಂಥ ಎಲ್ಲ ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್ ಆಗಿರ್ಬೋದು, ನಮ್ಮ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಆಗಿರ್ಬೋದು, ಈವನ್ ನಮ್ಮ ಟೀಚಿಂಗ್ ಫ್ಯಾಕಲ್ಟಿಗಳಾಗಿರ್ಬೋದು, ಈವನ್ ನಮ್ಮ ಮೇನ್ ಆಗಿರುವಂಥ ಸ್ಟೂಡೆಂಟ್ಸ್, ಅವರ ಪೇರೆಂಟ್ಸ್, ಅವ್ರಿಗೆ ಯಾವತ್ತೂ ನಾವು ಆಭಾರಿಯಾಗಿರ್ತೀವಿ. ಅದೇ ರೀತಿ ಇದೇ ರೀತಿ ನಿಮ್ಮ ಸಪೋರ್ಟ್ ನಮ್ಮ ಕಾಲೇಜ್ ಮೇಲೆ ಯಾವತ್ತೂ ಇರಲಿ. ಇನ್ನೇ ದಿನೇ ದಿನೇ ನಮ್ಮ ಅಡ್ಮಿಷನ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ, ಇದೇ ರೀತಿ ನಿಮ್ಮ ಪ್ರೀತಿ ಕೂಡ ನಮ್ಮ ಮೇಲೆ ಇರಲಿ ಅಂತ ಹೇಳಿಕೊಂಡು ನಾನು ಇಲ್ಲಿಗೆ ನನ್ನ ಕ್ಲಾಸನ್ನು ಮುಕ್ತಾಯ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಧನ್ಯವಾದಗಳು. ನನ್ನ ಹೆಸರು ಶಿವರಾಜ್. ಥ್ಯಾಂಕ್ ಯು.